Hello guys, welcome to another episode of Jacob Dev. Today's topic is Pydantic AI. So the Pydantic team has just released their latest LLM production-ready AI agents. So it's called Pydantic AI. So this actually is really good framework. If you go to the ai.pydantic.dev, you should be able to see their very well-written documentation, including how to set it up and different components like agents, dependencies, results, message, and chat history. They also include a couple of examples. You can go through all of that to get a sense of what this framework does. So in this tutorial, we're going to show you how to do this in Kaggle and the key features the Pydantic AI provides. So that being said, let's get started. So if you go to this kaggle.com, create a notebook called Pydantic AI. So first, to install the Pydantic AI dependencies, then if you use notebook, you also have to check if you have the nest async.io or async.io, because there's some issues with the notebook to run the Pydantic AI. So just keep that in mind. After that, make sure you install the examples if you want to check out how it works, right? With real examples, just install the examples package. If you want to do the debugging and monitoring, just use Logfire. They also provide that option. Then if you have the examples installed, then just do the copy and paste, which is to just use these Pydantic examples and copy to this Kaggle examples folder. You can copy to anywhere you want, but I just do it in the Kaggle working examples. You can see I copied everything in here, so it's Kaggle working examples. So they have a bunch of examples for different usage cases, so which is really nice. Then if you have to use Grok model or other models, just use the Pydantic AI Slim, this package, install the Grok. Or if you use OpenAI, you can just install OpenAI. If you use Vertex AI, just use Vertex AI. So you can install packages in this way, or you can use the other independent installation, which we're doing in this demo. And then after that, you can just be rest, and then basically all the dependencies are up. You can just go through the examples and test it out. So this one example we're gonna go through today is a online service customer agent example. So basically we try to get some information or advice for a customer, which is a part of the online store. So first we have to basically define a Grok key. You can just get the key from the Grok console, and you have to do this nest async out, as I mentioned earlier. In notebooks, you have to run this command so that it will work as expected, or you will error out. So then you have to define the payload context. So they actually offer a very good way to build a payload before you run the LLM pipeline. So for example, you have to using databases, you can use a Postgre or any other databases. So in this basically they say in reality you will be connecting to an external database, but in this example we're going to use the fake data. So let's say we define a method in this class. In this database class, it's just called customer name, and the ID is supposed to be 123. If it is 123, then return John. So you get the customer name by ID. And then the second method we define is customer balance. So if this ID is 123, and we just return the balance at 123.55. If it's not, then we raise an error. So that's a very straightforward class to get the balance for a customer based on the ID, and get a customer name from their ID. So just two methods. Then another class we have defined is a data class. It's called support dependencies. This is a part of the payload that club all the payload data you want to include. For example, the customer ID, and then want the database context, right? You can get all this database information in this class. You define that as a part of the dependencies payload. So this will be passed into the pipeline. So then you get the support results. So this is also structured class, so you can get the response as a structured data, so which is super cool. And so for example, this support result, you have support advice, block, card, risk, and you define what each field does. So eventually the pipeline will map the response to this structured results. So then after you define all these input and output schemas, you can actually define the agent now. So for example, we're just building this LLM using Grok. So you can specify the Grok, which you already had the API key defined earlier in the environment. So then you can now just use Grok and the model name, which is supported by Grok. In this case, will be 70B versatile. So then you also can specify which input you want, right? What type of input context. So they call it dependencies type. So steps type. So support dependencies, which include the customer ID and the database information. So that's your input. The output is basically result type. So then the support result as a structured output. And also the system prompt is you're a support agent in the online store. Give the customer support and judge the risk level of their query. Reply using the customer's name. So this is a system prompt. Then after you define this agent, you can say it as pipeline, but it's an agent. So, and then you can define the system prompt as basically using this input context, right? And then this will be another part of the system prompt. So then you can get the prompt from basically this DB, which is the input context. So you can just get the context dependencies and get the DB, which is included in the support dependencies class. So from the DB, you get this function in that class. This is one of the custom functions we define in the two functions in that DB class, right? So you get the customer ID, right? Put that in, so you get the customer name, and after that, you basically just return that prompt as a system prompt. So then in the tools, which is the coolest part, we define the customer balance. So this is how you actually trigger the tooling during this whole LLM pipeline. So this is the most useful function overall, I think. So then you can define the tooling, and this basically defining it as a decorator. You can also define it as a just a parameter. So you can go through the documentation in here. So you can also define the tooling as a parameter. You just put in the tools as an array and put it into the agent class. So that's it. So you can define the functions, and if you want to take the context, just use the context equal to true. If you're not, you don't want to take context, then just specify as false. So that's it. And then after you define this tooling, so then you just say, okay, I want the balance for this customer, which you can get from the input context. So as a balance. So when the LLM decides, okay, the question is about balance, then we'll use this method to return you this result. So in this case, we'll call this customer balance method. They give you the customer ID, and then you get the balance for that customer. So as simple as that. So this is basically a very straightforward tool calling or function calling. So then in the input, we can define the support dependencies. This is input, right? Input context, and then you specify the customer ID and the database context. And then you build the entire payload, which is, let's say, call it dips or the dep dependencies. Then passing the dependencies to this run sync method. So they support a run sync and run stream. So, but the Kaggle notebook doesn't really run the stream as the right way. So just don't demo that in the Kaggle notebook. You can run that in the local laptop or desktop. So then you can just run this run sync in the notebook and say, what's my balance? So I'm passing these dependencies, which all the input context you want the LLM to check. So then you get the data just using the result of data. So let's run that to see what it comes. So you get this support advice, which is a structured data. Remember earlier we said the structured data is support result. So they include support advice and block card and risk. So here they basically give you the structured data as a response, which is super cool. And the support advice is this, right? The balance is checked and then please wait for a moment. The block card is false and the risk is 0. And another support advice is, hello John, your current account balance, including pending transactions, is this, right? 1 to 3. Block card is false, risk is 1. So, super cool. And the other thing you can ask maybe is for like, I just lost my card, something like that. And then they will give you a response as well. So you can ask as many questions as you want. It's like the API generate endpoint in OpenAI, if you know what I mean. And then if you also get this, if you want to debug it, you can also get the result or messages. So this will give you all the debugging information through this run async process. So for example, you can see the system prompt is the your support agent, right? So this is a system prompt we define in the agent. Another system prompt you can see is what we define in the decorator, right? The customer's name is John, so then we define it in here, right? So this is a second system prompt, so they put it in here. Also the user prompt, which is what is my balance, so you can specify it in here. So that's what the debug information have, right? So two system prompt, one user prompt. After that, you get this tool calling, because the framework knows that you're asking for balance, so they just call this tool, so it's customer balance, and then they basically passing the parameter for the include pending as true, and that's it. So they also have a default tool, it's called final results. So for every pipeline call, it will just call this as a final result tool for the basically the tool chain. So then you got this response and the output to the client, right? So this is what we get from the support advice, and also the block card, and also the risk. So super cool. And so this is all you need to know for run a very straightforward like tool calling sample using Pydantic AI. So they have a lot of other examples you can find in here in the example section. So it's very cool, like a weather agent, which is so external API calling, and also like SQL generation RAG. So if you should check that out, it's really good examples. A last thing I want to mention is, so Pydantic AI is not the only framework that supports the tool calling. I have few videos for this. So first is for model context protocols. It's for Anthropic. They're trying to build a very generic AI agent production ready framework, but seems like the Pydantic AI is already building something very similar. So hopefully they're also building something very useful and very cool that people can just start using it. Right now I think they're still in a very prototyping phase. So I have this video for that. Another two videos I have is for LabKit. LabKit has a very similar framework as an agent pipeline as the Pydantic AI. It's really cool if you should check that out. They support both voice, vision, and text. So it's even better than Pydantic AI in that sense. So I have two videos for the LabKit. One is for the LabKit with the vision, and the other one is for LabKit with just voice only, which is local agent for voice interactions. This is a step-by-step guide on Kaggle, so you can build this, follow this tutorial. So that being said, hopefully this is helpful, and if you do like this video, please subscribe, like, or comment if you have any questions. Thanks for supporting the channel. See you in the next one.